pour water from the tap into the beaker. On the second beaker, I write cold water on it.
While we are still on diffusion, let us look at the rate of diffusion in water.
Okay. For such an experiment, we require 3 beakers. On the first glass beaker, I write tap water on it. And I put water from the tap into it. On the second beaker, I write cold water on it. And put into it water from the fridge.
For the third part of this experiment, we require boiling water. On the third beaker, I write hot water. And carefully pour into it boiling water.
Next up, we'll each put equal amounts of food color into each of the 3 glasses that we've prepared. We do this at the same time and see how fast the colored molecules diffuse. now put my timer to 1 minute and see the changes as they occur. It has now been 30 seconds and we have seen the changes as they occurred.
We can see that in the hot water, the molecules diffuse the fastest.
In the case of the tap water, we observe that the colored molecules diffused the moderately faster. As in the case of the cold water, it's diffusing the slowest. In terms of the color, we observe that the color is the most visible in the case of the hot water, moderately visible in the case of the tap water, and the least visible in the case of the cold water. Our observation tells us that the colored molecules diffuse at different rates. What can we conclude from this observation? This seems straightforward. Color molecules diffuse fastest in hot water and the slowest in cold water.
Can we use other materials and observe the same thing?
Yeah, I will use a powdered rim to check. For these experiments, we require new beakers. Just as I did before, on the first beaker, I write tap water on it. And I pour into it water from the tap. As I did before, on the second beaker, I write cold water. And put into it water from the fridge.
We require more boiling water for this experiment. Like before, I write hot water on the third beaker. And carefully pour into it boiling water.
We will now put equal amounts of powdered drink into the prepared beakers and observe the diffusion in 30 seconds. We will now put the powdered drink at the same time.
It has now been 30 seconds and we can observe that diffusion is fastest in hot water and the slowest in cold water.
We can perform the same experiment using tea bags.
But for that experiment, we require clean beakers. So we should wash the beakers we just used. We now have our clean beakers. So on the first beaker, just like I did in the two experiments, I write tap water on it. And I pour water from the tap into the beaker.
On the second beaker, I write cold water on it. And put into it water from the fridge.
For the third part of this experiment, I first get the boiling water that we require. Like before, I write hot water on the third beaker. And carefully pour boiling water into it. Now we each place a tea bag in the different beakers and observe the change that occur in 45 seconds. Enough time has now elapsed for us to notice the difference in the beakers. The tea diffused the fastest in the hot water, moderately faster in the water from the tap, and very slowly in the cold water. We can also see that the color of the tea is more noticeable in the hot water, slightly less so in the water from the tap, and not noticeable at all in the cold water.
I think we can now make a conclusion.
Yes, we can say that molecules diffuse fastest at higher temperatures.
Yes,
We agree.
But what explanation can we give for this? Why is diffusion fastest in hot water and slowest in cold water?
I think this is because molecules move faster at higher temperatures.
That is correct. And so, from this experiment, we've seen 3 important points. The first one is that molecules move from a region where they're found at a higher concentration to a region where they're found at a lower concentration.
The second point is that molecules diffuse through liquid or water and through gas or air, as in the case of the deodorant in the previous experiment.
The third point is that temperature affects the rate of diffusion. Molecules diffuse faster at higher temperatures and slower at lower temperatures.